Thank you very much, Anju, for this nice introduction. So I will elaborate a little bit more on biodegradability and also addressing one question which is part of our initiative, how to enter into a constructive dialogue with political decision makers. Yeah, and the example I bring with me, what I would like to present is the work of the AISE Taskforce for biodegradation, and there has been recently a presentation to some people of the European Commission in June, summarizing the work of this task force, and I will present these slides, give some insights, and give some comments to this. But I will first start again to address, before I come to the details of biodegradation, some basics to recap. I think this is important for all of us here in the room. Yeah, we talk about challenges and problems, and this is quite appropriate, but at the same point of time, we have to talk about the value polymers bring, for example, here in detergents. And it's not only about a technical performance of cleaning, it's also about a sustainability performance. Yeah? So polymers enable in detergents to at lower temperatures and to use significantly less water. Yeah? And the progress which has been made in the last 10 years is tremendous. Yeah? This is a message we have to repeat again and again. The second is, a polymer is not a polymer. Polymers are a very complex class of materials which a broad variety and broad properties. And this have to be also always included in our statements. The third point is about biodegradability. Yeah? Amy has started, but again, there are some basic facts about biodegradability which we have always to keep in our mind. The purpose of biodegradation, if we start with ourselves now after the lunch, it's about generating energy. And as a side product, CO2 and water, and we have to renew our cells. This is an essential task. Therefore, if you measure biodegradation as CO2, it never can be 100%. Never. And the same process takes place for microorganisms. They have the same purpose. And it's also clear that this is a time-wise process. And there are substrates which are easier to biodegrade and others which takes more time. For example, if you take a glucose syrup, you will metabolize this very, very fast. If you have to eat a heavy Swiss cheese fondue, it will take longer. Yeah? And it's clear to everybody that if you eat this, this will take longer. But at the other side, nobody will doubt that cheese is a substrate which can be biodegraded. Yeah? And this time aspect is very difficult to communicate, but continuously we have to do so. And of course, the task is, how do we measure biodegradation? Yeah? Amy has started this aspect to address. But if we look into the test methods, you see at the left-hand side, this is the way how it's today done. And on the top, you see the equation, what is done. And then you can measure this in different ways. But first, I would like to put your attention to the right-hand side. Amy already mentioned the famous 28 days, yeah, 60%. That is the target in the OECD 301 guideline. But what you can see in this slide, that normally, if you take glucose and a small biodegradable molecule, this happens relatively fast. And under normal conditions, you have a biodegradable polymer, what you can see here in the curve, it takes longer. And this has very simple reasons. A small molecule can be taken up directly by the microorganism. And this does not work for a polymer. It's simple too big. It's simple too big. Yeah? Like we have also certain food we eat, like a pizza, we cannot take it up at once. Yeah? We have to cut it down in smaller pieces, and then we can take it up. And this is the same what happens with a microorganism. So if they want to use a biodegradable polymer as food, they have to make an investment. Yeah? They have to invest in the production of enzymes the excretion of the enzymes, and then cut the polymer down and finally earn the investment, which means getting the oligomers or monomers, take them up and metabolize them. Yeah? These are some quite, for us as scientists, quite simple facts, but the communication of these basic facts is very important, because if this is understood, a lot of the following things will be easier. I will not go now into all the details of the test system, but just highlight some of the information which have also been given to the Commission. And what you can see here in this table, and you will see also after adapted form, is here in this table, different test methods have been summarized, and they have been assessed. What is the level of available information? What is the level of implementation? How practical it is? How costly it is? And so on and so on. And what you can see here on the left-hand side, the famous OECD 301 test. And what is important for this famous OECD 301 test, which, by the way, has achieved a high level of acceptance in the world, also with regulators, this test system has been developed for small molecules. The second thing Amy also already addressed, then the different ISO methods, ISO biodegradation standards, they have been developed for biodegradable plastics. So we have a standard for small molecules biodegradation, and we have standards for biodegradable plastics. But what we are looking for, the space in between for water-soluble polymers, this is not existing. Yeah? And this is one challenge. And then we have also what Amy addressed, what happens then in the field or how to simulate this. This is available, but of course, as you can see, quite challenging to do. Here again, a little bit more in depth, again, with respect to the time. The OECD 301 has also some advantages. Compared to a simulation study, it is relatively manageable from the cost side. Even, as we have pointed out, an assay system would be the optimal solution, but at this point of time, it's not available, and we didn't want to confuse the Commission with this. But what we can see that the different test systems which are available are a good basis. Nevertheless, also connected with this test system for small molecules, what has been also to be addressed, besides the short testing time, is the ratio of inoculum to chemistry, which means how many microbes are available to biodegrade the polymeric material. And also this ratio has been developed for small molecules. Yeah? It has been developed for the glucose syrup. But again, if you have a big pot of Swiss cheese fondue, one person might not be sufficient to take it all at once. Yeah? You need a group of people to manage that. And a similar situation we have here in the testing scheme. Last but not least, for the test, the simulation studies are done with C14 labeled carbon. And all people who have worked with C14 carbon know that this is quite challenging. And of course, it's very costly. And we have seen that we have to develop a lot of new biodegradable polymer, and it will simply not be possible to do for all of them C14 studies. So also here we have to look for alternatives. So summarizing that, and that was also the message to the Commission, there are certain good bases and starting points for further developing the test systems for polymers, but there are also significant gaps which have to be addressed. And this has been done in this AISE Biodegradation Taskforce. You can see here on the right-hand side, it's a group of different companies coming here together addressing this. We have also one member of the AISE task force here in the room, Natalie, and this work started in January 2022. And in the first phase of this project, the major task was to set a common basis, to assess the tests and the methods, and to provide basic data. And this I will summarize in the next slides. What the task force did is they concentrated on 5 polymers. So the first was to use also microcrystalline cellulose as potentially new reference materials, and then different other biodegradable polymers, and to test them mainly in the OECD 301, but also testing it under river water conditions. I will not go here into the details of all these biodegradation curves, but what you can easily see, most of the data are relatively consistent. Yeah? And that was a very important result of this study, is that the data are quite good reproducible. Yeah? Considering that they have been done in very different test laboratories and using different sludges from the wastewater treatment plants, yeah? Which follow certain requirements, but it shows you can compare this. What we clearly saw when testing biodegradable polymers is that the testing time of 28 days is too short, yeah? to really evaluate the full mineralization of the polymers. And last but not least, very important to look for references, and for good references for polymers, microcrystalline cellulose might be a very good reference to be introduced as new reference when we talk about polymer testing. This has been also published in this paper. Oh, sorry, I was too fast. Now in the next test phase, which has been started, other polymeric materials will be included, and there will be 2 aspects intensively investigated. The first is the question of diversity of the microbial communities, first in sludge. And there are also some good works addressing the core communities, how these core communities behave. And this has to be included, and as said, to investigate in a more appropriate way what is the right level of ratio between inoculum and to be tested polymer, yeah? To reflect that in an appropriate way. And this work has already started. So, what was the conclusion and what was the outlook? What was the message given to the Commission? Yeah? Again here, looking on the overall scheme of the test systems, but this, and this was also addressed in some presentations by Amy, but also in the morning, different aspects have to be addressed. Yeah? As said, the aspects of the method development have to be addressed with respect to testing time, but also an improved understanding of the enzyme and microbes is needed, as well as the further development of analytical methods to understand the biodegradation. And especially what you see on the left-hand side is a very important area of future work between industry and academia. Yeah? And this has a lot of potential. It's about understanding the biodegradation pathway, understanding structure biodegradation, and from this basis on to develop new appropriate structures. And as part of this also, Steve mentioned it already, predictive modeling can play an important role. And here we just included one example also from our work, which shows that it is possible to do so. Whereas the basis, and this you see on the left-hand side, and therefore the AISE work is so important, you need very consistent and accurate biodegradation data. That's the basis of all. Then you have to collect and analyze the data, and then with the help of the scientists, develop the models. If you have the calculation capacity, you can develop the first predictive modeling. What you can see here on the right-hand side, and what you do, you plot the real biodegradation value, which is on the y-axis, versus the biodegradation value of the model, which is on the x-axis. And in this case, you can see the accuracy is quite good with nearly 90%, which means in an optimal case, all values would be on the orange line. But I can confirm what Steve said. This technology has a huge potential, to change and also to accelerate the development. Another point which was also brought up to the Commission is there are different initiatives. Yeah? Also here, the initiative of the Royal Society of Chemistry, also as part of ICCS, there are ongoing activities, and especially on the left-hand side, cooperations between academia and industry. We have seen a great example, but there are other examples, and there can be much more engagement of the academic world. Last message to the Commission was, okay, what does that mean now for the future? And the statement, the clear statement here was, to adapt these methods and also to bring them in a standardized form on ISO level, this needs time. Yeah? And this is a very important message because especially the politicians in Brussels tend to decide very fast and to believe they are the only owners of the truth. Yeah? And therefore, it was very important to bring across this very clear message, even with the full willingness of industry and also certain academic groups to investigate this. It will take time. Yeah? And overall, that have been the 5 key messages, and I will not go into all the details. But that was a clear message. The AISE Association, and I think this is the same for our initiative here, we seek for regulatory engagement and partnerships to jointly address these challenges. Yeah? And as a positive outcome of this meeting in June in Brussels, the AISE task force was invited to report twice a year to different members of the Commission what is the progress. Yeah? And I think this is also for us here, communication is decisive. Last but not least, we would like to make an announcement for you to engage. Anju and myself, together with Amelie, we have applied for a session at the next CETAC conference in Vienna. And the title of our session is really Advancing Home and Personal Care Formulation through Novel Test Methods, Environmental Impact Assessment and Regulation. It's a very broad topic, and we want to invite also here all people to consider to send an abstract to this conference, because it would be very helpful if in this environment of the CETAC, which is more with respect to regulatory, etc., we could also bring in a session maybe with more innovative aspects. You will get also some written information, but that would be our message from Anju and my side. Please engage and bring in your abstract. Thank you very much for your attention.
Thank you very much, Andreas. Are there any questions? I'm not sure if there are any questions.
I saw that you mentioned the standard method, which has a 28-day kind of yes or no result. And I can understand that you're trying to find something that's more predictive in a shorter timescale for screening purposes and things. Does this relate in any way to, I don't know how to put this, are you somehow proposing a change in the judgment of what is acceptable or unacceptable in biodegradability terms, or is it just a change in method?
It's a good question. So, on the one hand side, there has to be the work on the standard and to develop standards which are appropriate for biodegradable polymer. Yeah? This, I think, is clear. On the other hand side, there will be the question, okay, what happens if you bring it to soil in Sweden, in the UK, in Sicilia, and so on and so on. It will not be possible to do all these biodegradation trials with different soils and so on. And therefore, predictive modeling could be a tool, yeah, to investigate that. And at least what we see, there is a certain openness in the European Commission as part of this twin transformation, digitalization, sustainability to consider such type of tools. So maybe in some years we have the testing regime, but in addition, predictive modeling tool which could give certain data and increase then the confidence and acceptance that the new biodegradable polymers developed by Croda or BASF or whoever are really biodegradable under the different conditions. So it's not one or the other, it can be both.
Sorry, it's just that one point, some of the graphs that you were showing made me think that there's an implication that some polymer that you'd newly developed that wouldn't have passed the old-fashioned 28-day test had a different shaped curve. I thought there was an implication there that you were saying, oh, it's still biodegradable, but it just takes longer to biodegrade. But there must be a reason why, I know it's arbitrary, 28 days, but there must be a cut-off point beyond which we say as a society that this chemical is too long-lived and causes harm in the environment.
So probably these, let's say, time frame of 60 days would be appropriate, yeah, to reach a certain level. And in addition, of course, it has to be shown what is the environmental fate and that there is no harm. Yeah? So these are different levels of providing evidence. Yeah.
Well, thank you very much, Andreas. Great presentation. I have one question.
Yeah, please.
That's okay. You know, plastics were a complicated type of polymer. You know, industry and regulators have made mistakes from it. Is there something we can learn from the plastic history that we should not repeat in the world of PLFs?
Yes, I think there are probably at least two learnings I would see. The first big mistake was to claim that polyolefins can be biodegradable materials. Yeah, that was a big mistake, confused the regulators, confused the public. So to make clear from the beginning what is biodegradable and what is not, and what is the right end-of-life solution. That should be made very clear. And I think the second, what we can learn is to be proactive. To be proactive in the development, to be proactive driving standards, communicate proactive. That's the only way to go.
Excellent. Well, thank you very much, Andres.